In this OGE, we're going to learn the completing square method. So the complete square method based on a special factorization argument. So for example, let's look at this special identity. So we know from algebra, so if we have x plus b, if we square this, what's going to happen? So you can use the FOIL method or the distribution, write in two terms. You know that the terms are, first term is x squared, and the middle term is 2x and b, and then b squared. That's what you get. You can get this from either foiling or just distribution. But we're going to rearrange the terms so that it's going to helpful for the argument. So what we're going to do, we're going to leave x squared here. I'm going to get the x term, right? I write the x term first and write 2b here. And then we have b squared. So let's try to identify what these terms are. So what we really need is, our focus is on this special term. So we try to figure out what that term would be. So, and you can see that this term is simply, so let's look at this term. Okay, so when you look at this term, and you can see b is simply half of the coefficient of x. So you can see there's x term here. So what is b? B is the half of 2b. Okay, so that means we can write this one as, so we're going to say, so what is this term? This term is half of, so half of the coefficient of, x, half of the coefficient of x. Because we know that when you look at the expansion, you have 2b, but what we really need is b. So b is simply the half of the coefficient of x. So the coefficient of x is 2b. And then we have another special term. We're going to give you a name for this one. This I like to call this the magic term. So what is this magic term? Why we call this a magic term? Because that is the term we're going to add to the expression to create this special factorization. So what is this magic term? So it is simply again the half of the coefficient of x squared. So you can square this term. So that is how you get the that last term or the magic term. So let's really look at let's look at a problem and see how this argument works. So we can do this problem. So let's say we have fx equal, let's say 2x squared minus 3x plus 7. So this is not a really easy problem, but this is like a little difficult problem, but it's okay because we try to understand the argument here. So what you notice, first thing you notice is, you can see the coefficient of x squared is not 1, it is 2. So if you see something other than 1, what we normally do as the first step, we try to factor out that term. So you can say 2 out as a factor. That means you divide the terms inside by 2. That means if you take, so you're going to get x squared here. So here we divide by 2, that means it's going to be 3 over 2x. And then what I'm going to do, I'm going to leave a space here and write 7 outside. Okay. Now what we try to do, we try to calculate that magic term here. What's the magic term? We look at the half of the coefficient of x. So you can see the coefficient of x is this whole term. So what we're going to do, we're going to take the half of that. So if you take the half of that, so which is negative 3 halves. So we can take half of that. So if you take the half of that, so that means you multiply by 1/2. That's how we take half. So that means this is simply negative 3/4. So that's what you get as the half of the coefficient. So what we really need is, we're going to square that, and we're going to take that, we're going to add that term. So that means if you square this, so what are you going to get? You get negative 3/4. So you can square that. When you square that, the negative sign doesn't matter. You square the top and you square the bottom. So that's what you get. So that is the magic term we are talking about. So that is the term we're going to add and subtract. So now what we're going to do, we can do interesting thing, because we want to make sure that the expression is still equals to what we have earlier. So that means what we're going to do, this is always an addition part, so we always add this. So we add that magic term, that means 9 over 16. That's the half. That is the square of the half of the coefficient. Okay, you take the half of the coefficient is square. So that is the magic term. Now what we can do, we add subtract. But be careful when you add that term. Actually, we add this times that. So you can see there's a multiplication. So we did not just add this. We add 916 times 2. So that means we have to subtract that whole term. So we're going to subtract that. So which is simply, so we're going to multiply the 2. That means which is 9. If you multiply 916 by 2, you're going to get 9 over 8. Okay, so that's what. So again, so what is this? Where this coming from? So this is 2 times 916. Okay, that. So what we do, we add and subtract. Add and subtract, because when you add subtract, they cancel each other. Okay, now everything looks great. So what we're going to simplify. So which is 2, and since we add this magic term, this is automatically a square. So that's the whole point. What is this? It is x and half of the coefficient of x. So that means this is negative 3/4. So we just did the half of that. So always, this is always the case. It's always the half of the coefficient of x and squared, and then we're going to simplify the other parts. And how to simplify this? What we normally do is we're going to multiply these two and add that. Okay, so it's a multiplication, and then we can add. So that means you're going to get so 7 times 8 is 56. So we have 56 minus 9 divided by 8. So that means you're going to get 2x minus 3/4 squared. And if you simplify, 96 minus 9 means 47. So you get 47 over 8. So that is the complete square for that problem. So it's not that difficult, but this is how the algebra works. So this is how you do the problem, but I'm going to show you like one extra step. Sometimes it's helpful in pre-calculus or algebra. So this really going to help you to graph this quadratic function, because the reason is you can see. So this is going to because when you graph a quadratic function, always there's a vertex. Okay, so what's a vertex? So if you I'm just gonna like do a general situation. So if you graph a function like quadratic function, there's a vertex. That means that corner. That corner has a x coordinate and a y coordinate, and this clearly give you the x coordinate, y coordinate. For example, if you look at this part, so this is the x coordinate without the negative sign. So that means 3/4 in this problem, and then this is going to be the y coordinate. Okay, and again with the sign, So this is 47 over 8. 47 over 8. So good. So that means it's going to help you to graph the function. So if I do it in a neat fashion, so what we get is, so these are the two axes, and then we have those two numbers. So one number is 3/4. The other number is 47 over 8, so which is slightly less than 6. And then we also so that means that's the vertex, and also we can find the y-intercept. Y-intercept means when you plug in x equals 0, and you can see that if you plug in x equals 0, you're gonna get 7. So that is the y-intercept. That means this graph should pass through that number. So that means finally you can plot this curve. So it's gonna go like that and go like this. And so remember, this is a parabola, so it should be symmetric, and that's the curve, and that's exactly that x y intercept. So, and you can see that you get like a really neat graph in this case. You cannot just get these kind of graphs using plot points. The reason is we really don't know where the vertex is, where this turning. So that means do not use the plotting points for this kind of situation. It should be better to write in this vertex, this squaring like completing square method, and then we use the use that points, use the x coordinate and the y coordinate to of the vertex to graph the function. So this is how we use the completing square for a problem. So I will write the vertex here. It is 3/4 and 47 over 8. And also you can try these problems as practice problems. So try these problems, and you can find these answers to these problems in the practice problems video. Thank you.